Now we look at the other positions, for other positions of object, how the image is formed. That is, we can think of the other positions like object is at object distance u is equal to u is greater than 2f. That means beyond the center of curvature. And here image formed, image is at here when it is at beyond the 2f, we have already seen this. I mean at infinity we have seen, and when it is beyond 2f, it is going to be between beyond 2f1. I am looking at between f2 and 2f2 it is going to be f2 and 2f2. And the nature of the image is going to be, we'll just write down that. First let us write the diagram, the ray diagram, how it is going to be. So this is the lens I have, and this is the principal axis. Let us say this is the principal axis. Now this is 2f1 and this is f1. Let us say this is f2. This is 2f2. So see here, if at all an object is placed over here beyond 2f1 I said, and one point you need to remember, whenever a parallel ray goes, so the parallel ray goes from the object, then it will be passing through the focus over here and will be moving in this direction, and then whichever is passing through the center, so this is the center of the lens, will be passing like this, undeviated. That means it is going like this. So obviously you are getting the image formed over here, that is between f2 and 2f2. So see here, if at all I suppose the size is AB, here it is going to be A dash B dash. And what is the nature? Inverted and real, and magnification is going to be less than 1 and negative, less than 1 and negative. And what else you can think of? Inverted, real, and magnification is going to be this much. These are the properties you can look at for the image formation formed between f2 and 2f2 in case of when object is taken beyond 2f1. Similarly, when you look at the next case, object distance is u is equal to 2f1, let us suppose. So it is placed at 2f1. Then image is also formed at, image distance is v, that is 2f2. Image distance will be 2f2. That means when object is placed at 2f1, I'll just look at here. This is the lens I have, and now I'm going to look at how the ray is formed. And here it is, let us say 2f1, and this is f1, and this is f2, and this is 2f2. Now look at this. Here, when object is placed over here at 2f1 I said, so then the ray which is traveling parallel will be passing through the focus and coming over here. Then the ray which is passing through the center will be meeting this at the distance, will be meeting at the distance here. That means it is somewhere here. So this is going to be the ray diagram for the second case. That means the size AB is going to be same as that of A dash B dash. So here size is going to be, and here one more thing, size is going to be diminished here in the first case, diminished, and here it is going to be the same size. The properties are going to be same size, inverted, inverted, real. And magnification, when you look at the magnification, magnification is going to be 1 and negative. So this is what the ray diagram in case of object is at center of curvature, you can call for the second lens, and image is formed at the center of curvature of the first lens. Just similar to the spherical mirrors what we have seen. Now look at the next case, that is fourth case. We'll just look at, if at all the object is moved to 2f1 to f1. So obviously it should be beyond the 2f2. So if at all I take object distance I am taking u is between 2f1 and f1. Image distance is going to be, image position is going to be beyond 2f2. Beyond 2f2. Then how the formation takes place we'll just look at. So let us write the diagram for this. So this is how you can write the diagram. So this is the lens what we have. This is the lens what we have. For this lens, let us say this is going to be the principal axis. This is going to be the principal axis. Now object is between 2f1 and f1. That means let us say this is 2f1 and this is f1. Then object is placed over here. Then what happens? Let us say this is 2f2, this is f2, and this is 2f2. So here a parallel line falls on this, will be moving through the focus and will be going like this. Then the line which is passing through the center, will be traveling like this, will be traveling somewhat. This is the path how it travels. So if at all you join the rays over here, it is coming to be A dash, B dash, and let us say this is A, B. So here you can easily note down that A dash, B dash is more than AB. Therefore size, magnified, inverted, these are the properties, inverted, real, and magnification is going to be greater than 1 but negative because it's a real image. So this is how you can denote the notation for the position of an object is between 2f1 and f1. This is a thing you can get. Similarly, you can think of another case, that is, we'll just move the object to, object is at focus, f1. Object is at focus now. I'm just moving from infinity to towards the center of the lens. Then image is at infinity. So obviously when object is at infinity, the focus is at, the image is at focus 2. Here object is at focus 1, then image will be at the other side, infinity. So how it happens means, you can just think of a lens is here, and now I am just taking the principal axis. Here it is 2f1 and this is f1. Then you can think of this. So here it is going, this is f2, this is 2f2, and now it is going in this manner, whereas this is going in this manner, and they never meet. That means image is formed at infinity. So this is how it takes place. So magnified, so properties you can take, real, magnified. So m is far greater than 1 but negative, and inverted. So this is the property of the image when it is placed at the focus of the first lens. So these are the various ray diagrams in case of the convex lens. And one more ray diagram we have to look at. We'll see that in the next video.